Let's set up a system of three equations with three unknowns. And let's make it ready for solving using matrices. So if the problem goes like this, you have 48 coins and they consist of dimes, nickels, and pennies. They are worth $3.56. In addition to that, you know that you have 2 times more dimes than nickels. How many of each coin do you have? Well, let's just set it up like this. If we just count coins and disregard the value of each coin, so if we just physically count pieces of metal that we have, then that's going to be how many dimes do we have plus how many nickels, and then how many pennies. So when we count each of them, we'll end up with 48 coins. Now, when we count the value of each, we have $3.56. So if since dime is worth 10 cents or $0.1, we can say 0.1 times each dime we have, plus 0.05 times each nickel we have, because each nickel is 5 cents, so $0.05, and then plus $0.01 that each penny is worth times how many we have. And then this sentence right here says there is 2 times more dimes than nickels. So we can say that we have 2 times more dimes than nickels if we say something like this: 2 times nickels equals to dimes. Now, for solving this algebraically on paper, this will be good enough. We just start solving. But if we want to prepare this for matrices, we need to actually organize this a little bit more. Now, first two equations are actually lined up nicely, but we need to do something with the last one. Now, what do we need to accomplish here? Well, each dime needs to be lined up, so it needs to be dime under dime, nickel under nickel, penny under penny, equal under equal, which is very important, and then constant under constant. So the first two equations, as I said, they're already lined up. We just need to rearrange the last one. And all we need to do is just take d to the other side. If we do, we end up with 2n minus d equals to 0. Now we need to reorganize this so we have it in the same order as the other two. If we reorganize them, then we'll end up with first equation being d plus n plus p equal to 48. Second equation, so I'm just copying first and second, is 0.1 times d plus 0.05 times n plus 0.01 times p equal to 356. And then 2n goes under here, so it's plus 2n. Minus d goes where the d's are, so minus d right there. And then we don't have any pennies, so we can just put plus 0 if we want to. And then equals to 0 on the other side. Now I put 0 here just because we need it for matrices. Other than that, it's not really necessary. Now that we have them lined up, what we need to do is make matrices. And matrices are just areas of numbers. and they look like this. So we use a big bracket like that, and then we put the first matrix that we are going to make is going to be matrix of coefficients. And coefficients are just numbers in front of each variable. So this D right here has a 1, this one has 0.1, this one has a -1, this one has a 1, this one has 0.05, and so on. So all we need to do is copy those coefficients. So the first one is 1, 1, 1. The second one is 0.1, 0.05, and 0.01. And then the last one is -1, and then 2, +2, 0, and then we close it off with a big bracket like that. That bracket doesn't really look too happy, so let's try to make a better one. No, not that this one is any better, but okay, let's leave it like that. Okay, so this is our coefficient matrix. Coefficient matrix. Now we need to make a matrix out of the constants. And that one will be just 3 numbers. So 48, 356, and then 0. And then we just close it like that. You will often read in literature that this is actually called a vector, but let's not bother with that. So this here is the constant matrix. Now let's just talk a little bit of how we do operations with matrices. We can multiply and divide and add and subtract matrices in a similar way we do it with numbers. With division, we actually don't just divide, same as we do with numbers. We actually need to multiply by an inverse. Well, that's how matrices kind of work. So if we have, let's say, a matrix A times a matrix X equals a matrix C, then if we want to solve for X, let's say that's the variables matrix. So let's say these here are coefficients matrix, variables matrix, and then constants over here. Now if these are just numbers, we would just divide both sides by A, and we will get X by itself. But with matrices, we can't just directly like that just divide. What we need to do is actually multiply by inverse matrix, both sides. Now if we do that, then these two matrices will actually make so-called identity matrix. Which is kind of equivalent of 1 in multiplication. You know, like if you multiply something by 1, nothing changes. You just still have that something. So that's what identity matrix kind of does in the world of matrices. So now to solve for our variables, what we need to do is multiply the coefficient matrix, which is this one, inverse of the coefficient matrix, with the constant matrix. So we have our coefficient matrix right there, we have our constant matrix right there. All we need to do is make this one an inverse. And this would actually suffice if we use calculators if we have a matrix and then we raise it, we make an inverse of it. And this is the notation there. So now we are actually ready for using these two matrices here to actually plug them into our calculator and get our answers for x, y, and z, actually in this case for d and p. To get this actually solved by using matrices, please watch the video named Matrices number 1. I hope to see you there. Thanks for watching.